I'm going to talk about some SRIOV configuration tools I've been working on, stuff that's going to help people deploy SRIOV to make it less painful. In fact, a lot of this was kind of prompted by some pain that I was experiencing as I was actually trying to do some work with SRIOV. First thing we're going to do is we're going to start with stupid engineer tricks. I'm going to explain an extremely complex technology in 1 minute to the three of you guys here who don't know what SRIOV is. So get your watches out. I can't quite see the second hand on the clock back there. So step one, this is how everything used to be. This is how most networking works in virtualization right now. We all do it through software. We have a virtual switch. We emulate the NICs. We use a device driver in the VMs that talks to some other piece of software on the other end that isn't a real piece of hardware. Everything's software, no hardware involved at all, except when you get down to the actual physical NIC, which is owned in Xenalyze domain 0. It's flexible. It's not particularly fast. Then we got direct assignment. In Intel speak, that's VTD. I don't know what AMD speak is for that, but it's an IOMMU. This lets us take a physical NIC and directly assign it to a VM. The VM actually runs the real device driver for the real NIC, which talks to the real hardware, which gives us really good performance, near native, usually with a little extra CPU overhead, which is great. It works really well. It's fast, but it's not very flexible. And all the other VMs in your machine are out of luck. They're still using software. So SRIOV tries to make this the best of both worlds. We take one NIC, we have it turn on its little SRIOV registers, and all of a sudden it gets a whole bunch of virtual functions in PCI. And all these virtual functions look like real devices. They're not real devices. They all point to the same piece of hardware. But you can then take one of those and assign it to your VMs. And you can assign the same hardware, little pieces of it, to multiple VMs. They all run a real device driver, usually a subset of the main device driver. They all talk to the NIC directly. So everybody gets the good performance. Everybody gets to talk over the wire, and everybody gets to do it. So there's 1 minute. How did I do? Good. I did it at about minute 20 in my dry run last week. There's some disadvantages to SRIOV, and Ian knows them well. He and I were talking about that Monday. It kind of undoes the whole idea of virtualization because now you're not virtual anymore. And there's some real problems that we're still figuring out how to do stuff like migration and things like that with this. The current solution people are thinking about is kind of something with bonding and still have a virtual NIC in there and hot plug out the VF. The VF is the virtual function of the actual physical NIC. And that's still kind of, we're figuring out. This is a real early technology. It's kind of toddling along. This is what we're selling. You can actually go buy these NICs today. These are Intel NICs. The 82576, which is what we called Cavala. I did a lot of the driver work on that. It's a gigabit NIC, so in terms of actual performance, you don't get a lot from SRIOV. You just don't need it. Even with software, you can easily saturate a gigabit NIC. But a lot of people have liked these because they're good for experimentation, because everybody's got gigabit switches. Not everybody has 10 gig switches. And these are for sale today. The quad port one, because of the switch on the quad port right now, you can't do SRIOV with the quad port. But we have another one that we're working on, and I don't even know when it's coming out. It's probably sometime in 2010. You'll be able to get a quad port that will do the SRIOV. We're also seeing these down on motherboards on a lot of servers. I've got a couple of Supermicro servers back on my lab that has one of these down, so you get 2 ports right on your motherboard to do SRIOV. So it's good to experiment with. The driver for that, you use the regular IGB driver for your physical function. When you enable SRIOV, it's a command line option to the driver. Then in your VMs, you run the IGB VF driver. Not the same driver, it's a different driver. And that driver is in the upstream kernel. It's in RHEL 5.4. It's in the XCP 0.1.1. So it's something you guys can play with right now. The 599, that's Niantic, if you've heard any Intel rumors floating around for that one. That one gives you 64 VS per port, which you really need because it's a 10 gig card. And we've shown you can actually saturate a 10 gig wire. You don't even need 64 VFs to do that. You can do it with 4 or 8. So you get really good performance. That is a dual port 10 gig card. So you can get 20 gigabits if your internals of your system can handle it. That also uses the IXGBE driver like you'd use without SRIOV. That also works with the physical function of the driver. And in your VMs, you'll run the IXGBE VF driver. That's in the upstream kernel. It's not yet in any distros, but I'm sure that's coming. So here's the pain. My boss said to me, Mitch, go and figure out this SRIOV stuff because we want you to be maintaining the drivers in the future. And I said, you betcha. Well, one of the engineering decisions that was made when we first started doing these drivers is that when the physical function driver comes up, it sets up all the VFs and it assigns the MAC addresses just randomly. It just pulls some random bytes and says, here's your MAC address. And there are some engineering decisions that went into doing that. And there's a lot of pros and cons, but basically, if we had actually assigned a MAC address for each VF, we would have burned through our MAC address space pretty quickly, especially with Niantic. You know, you can have 64 VFs, assign 64 VFs to the board, or 64 MAC addresses to the board. You're going to run out of MAC addresses pretty quickly, especially considering that a lot of people probably won't turn on SRIOV, or at least not right away. The real problem, though, so random MAC addresses works okay. You can do it. The real problem is that every time your host reboots, or every time you reload the physical function driver, you get a new MAC address. So then you crank up your VF, and the operating system in your VF goes, oh, hey, look, I got a new device. It looks just like the old one. It's in the same bus and device, so you put it in the same slot, but must be a new device. It's got a new MAC address. And so, I'll give you a new interface. So now instead of ETH0, you got ETH1. And he says, oh, it's a new one. I'll give it DHCP. And everybody's happy, except when you reboot your host 50 times, and now you're up to ETH51, and you got all these leftovers in there that will never, ever come back. Well, and it's fatal for fixed IP addresses, because every time you reboot your host, now you've lost your fixed IP addresses, because they're attached to the old interface with the old MAC address that'll never come back again. Guess who uses fixed IP addresses in his test bench? So I had some pain. If you don't know who that picture is, the door's right there. So, of course, I realized we needed to do something about that, and sooner rather than later. We always kind of knew it was an issue, but it needed to happen quickly. So, of course, step one is have a meeting. We actually had several meetings, because that's the Intel way. I'm sure none of your other companies you guys work for do things like that. But meeting, and then a lot of email. And finally, they said, well, fine, Mitch, you go fix it. So I had to actually touch a lot of parts to get that to work right. I had to touch the PCI subsystem to export a couple APIs, just little stuff. I had to add a few more NetDev ops to the kernel net device layer. I had to work in the RT Netlink interface to be able to get data in and out of user space. And let me tell you, if you've ever worked at RT Netlink, or if you've never worked there, don't. Oh, good Lord. You got data structures named Q, you know. Anyway. Then I updated the driver to actually support these new net device ops. And finally, edit IP route 2. So that's when you type IP at your command line, that's what I've updated. That stuff's all done. It's all pushed upstream. Here's how it works. IP link show normally will show you just your links. Now it will show your links plus all your VFs. So what you see there at the top is the random VFs, the random MAC addresses that got assigned when the system booted up. Then I can run IP link set dev ETH0, VF0, MAC, blah, 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 blah. And it'll stick it in there. And in this case, I've also actually added a VLAN to the NIC. Then it shows up again, it shows up here. And that'll stick until obviously you assign a new one or you reboot again. Then when your VF loads, of course, if you script this correctly, when your VF loads, your VF is always going to see the same MAC address. Your VF's going to be happy. It's not going to lose its fixed IP address. You can run all your scripts that depend on that. It's actually just an extension of what we have today. Yes. Yeah, that's the plan. We're not there yet. Now, this code has all been done in the Linux kernel, well, except for the user space bits. So this will obviously affect any and help any virtualization solution, including the one that starts with the letter K, handle SRIOV stuff more correctly. So obviously I already mentioned it, but we can actually take, and this is something a lot of people wanted actually, take a VF and hence the VM attached to it and put it on a VLAN. So all its packets come out tagged, all the packets come in, get filtered and stripped correctly. A lot of people call that port VLAN. It's a little silly because it's not really a port anymore. The funny thing was after I wrote this code, we probably got 4 phone calls from customers saying, we really want to do this with SRIOV, make it work. And so we actually got to say, oh, hey, guess what, it's done, and we actually looked really good, even though it just got lucky, I guess. The other thing is I put in the code in the interface to do transmit rate limiting. Real simple, it's not true traffic shaping, but you can basically say, hey, this particular VF cannot transmit faster than 20 megabits a second. That's all you get. And that's the policies enforced by the device. That's in the interface. I haven't added the driver bits yet. There was another patch hanging out that did something similar through sysfs, and I wanted to see how that settled out first. And basically that's gone away, so I need to take the actual guts of that internal driver code and add it back in and then push it upstream. So it's there on the command line. You can type it in IP, but nothing will happen at the driver level. So near-term needs, real near-term need, of course, is 10 gig support for this. I did it in the IGB driver because that's the hardware I had available to me. Greg Rose, who is another engineer who works in my group, has done the 10 gig support. It's in our validation team right now, so I expect you'll see patches going out to NetDev probably next week, maybe a week after. So that, obviously, we're trying to get that into 2635 since it's too late for 2634. Then we got to get the distros to take this stuff. So the patches need to be backported to Zen Cloud Platform, need to be backported for RHEL 6. And then you need to add support to your VM management tools so that XM or XL or whatever you want to use knows what to do with that. Wire that in somehow. So that's when you guys get to do that. And then the real problem, of course, is migration support, and there are a lot of different ideas and ways to go about migration. The current thinking, at least for us in terms of near term, just to get something working to show people, is channel bonding plus hot plug. So you'd hot plug out the VF, it would fail over to the software interface, you'd migrate, then you'd hot plug in a new VF, and then the bonding would go, hey, look, a new interface, and it would switch over and you'd be all happy. And of course, that's not transparent to the guest, so it's not a great solution. And I know there are several other ideas being bandied around about how to do better migration with SRIOV, but at this point, that's kind of the pain you're going to have to go through if you want the good performance of SRIOV. And that also is going to require more support for VM management tools. A real problem we've got right now, and this absolutely is broken and won't work, and I'm warning you about it, that's what this is. If you have a system where you have both software emulated NICs, so on a bridge in domain 0, and some SRIOV devices, also on the virtual functions, they can't talk to each other right now if they're going over the same NIC. And the reason is that the switch inside the NIC, it's not really even smart enough to be called a switch. It's terminally dumb. And it's all tied into the receive address registers that the actual virtual functions use. So if you were to want to have a virtual function talk to one of your virtual NICs, then you got to tell the switch the MAC address of the virtual NIC that's on the back side of the bridge that the physical function is attached to. And there's no mechanism for doing that right now. There's nothing for doing that. There's not even a hack for doing that at this point. So if you intend to do this type of configuration where you're going to have some of your devices using virtual NICs and emulated NICs, and some of your other virtual machines using SRIOV, you got to have two NICs. We're thinking about how to fix this. It's probably going to happen through Open vSwitch, and Greg Rose, whose name I dropped earlier, Greg's actually looking into that right now. He's tearing the code apart and figuring out what needs to happen to make Open vSwitch aware of the real simple switch that we have on our boards and allow it to configure that. So that work is ongoing, but I think it's going to be a while. Open vSwitch is really not there in terms of handling hardware devices at this point. There's some documentation, that's about all there is. So this is a warning. We know it's a need, so we're getting there. So at this point, it's a nice short presentation. I hope I kept you guys awake. We need some help. We want to know what you guys need. What have we missed? What is going to make it less painful for you to use? That way you'll buy more Intel NICs. See, that's the real deal, right? I'm not even a salesman, I'm just an engineer. So feel free to comment now, but I'll probably forget it. So please, if you've got comments or questions and you'd like to see features put in place, email me and email Greg, and that way we can respond to you that way. Questions? You're going to, okay. Okay, so did you hear that question? Okay, so yeah, go ahead and unplug me because that's my last slide. If you configure the guest for a port VLAN using the mechanism I described, and then the guest wants to go add VLANs, what happens? And the answer is the guest will fail. Unfortunately, in Linux, if your Linux is running in a VM, there's no way for it to tell because there's no mechanism to tell the VLAN code, hey, you tried to enable VLAN and I couldn't, because it's a void function. So there's no way to tell it that it failed. In Windows, the VF driver in Windows will actually go ahead and fail the call, and you'll get a warning message.
Is that random assignment of max particularly to Niantic, or is it? I mean, is that expected to be generic from across vendors?
I think you're going to. I can't talk for other vendors. You'll see it. You'll expect to see it generically across Intel devices that do SRIOV. We don't want to burn that many MAC addresses when you're not going to turn them on.
Quick question on the VF MAC assignment. Is it a one-to-one correspondence always, or can there be a multiple MAC to VF or multiple VF
No,
to?
one MAC per VF through this functionality.
So that's Niantic specific, or is that going to change?
That's the interface actually just only thinks about one MAC per VF.
And where are you guys on EVB jail support? What's the track there?
Pardon me?
EVB support in general.
EVB.
That the last mile physical switch is going to manage those virtual ports to some extent.
Yeah. At this point, I think that's going to be in Greg's backyard. So I would email Greg Rose and ask him that question because I don't know the answer.
I mean, it doesn't pose significant additional complexity on host drivers, correct?
Yes. We don't know how much, though. Anybody else? All right, thanks.